Hey class, this is Mr. Bassler here. Welcome to our first community day. Today we're going to be taking notes on page 112 in our binders, and we're going to talk a little bit more about functions, mapping diagrams, tables, and graphs, as well as talking about discrete and continuous functions, all right? So follow along, make sure you have a writing utensil, and again, we're on page 112 here. All right, so example 4 says to create a table mapping in a graph given the following coordinates. All right, so we have these set of coordinates here, which is basically going to be like a discrete function here. So our first task is to create this table, right? And table is at x, y values. All right, so we're just going to list out those same exact coordinates on a table here. All right, we're going to take that first ordered pair, -2, 3. Our second ordered pair is 4, 6. We have 5, 4, -2, 6, and 5, 1, right? We're going to just list them in the same exact order as our table is in our coordinates, all right? So now we're going to plot all these points on this graph here, all right? Remember when we graph our functions here, right? We got the x graph going left, or x-axis going left and right, and we got our y-axis going up and down. All right, so -2, 3 means -2 on our x and +3 on our y-axis. It's going to be right there. All right, we have 4, 6. I'm going to put that one in red. So we have 4 to the right and 6 up. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6 up. That's going to be our second point there. Next, let's go with green at 5, 4. So again, that's going to be 5 to the right. 1, 2, 3, 4, 5, and 4 up. 1, 2, 3, 4 up. And our next point, let's go orange here at -2, 6. That means we're going to go -2 on our x, and we're going to go 6 up. 1, 2, 3, 4, 5, 6. And then our last point here, it's 5, 1. So 5 on our x, 1, 2, 3, 4, 5, and 1 on our y will put us at right there. All right, so that's how we're going to plot our points on our graph here. And the last here, we got our two ovals. We're going to make our mapping diagram, all right? When we make our mapping diagram, this is going to be a little different and possibly a little bit new. We're going to list out our elements in our domain, or our x, on our first oval here. And then we're going to list out all our elements, or my values of y, in my second oval here. And then we're going to make the connections based on the ordered pairs here. All right, and when I list out my values here, I'm going to list them out in order from least to greatest. All right, so I'm going to look at all my x values. I got -2, 4, 5, -2, and 5 again. All right, but I'm not going to repeat any of these values. I'm just going to list it in order. All right, so my first is going to be -2. My next x value is going to be 4. And then my next x value is going to be 5. All right, so now I'm going to do the same thing now, but with my y values. All right, again, I'm going to list them in order from least to greatest. So it looks like my smallest value is 1. Then I'm going to go to 3. And then I got 4. And I got 2 6s, but again, we're just going to list it one at a time, or just list one of them. All right, now I'm ready to connect my elements here, right? I'm going to connect my ordered pairs. All right, so I'm just going to go back to my original problem here, right? -2 goes with 3. So I'm going to start with my domain, and I'm going to go to my range. I'm going to start with my input. I'm going to go to my output, right? So next I have 4, 6. So 4 is my input, and 6 is my output. All right, 5, 4 means I'm going to connect this 5 with a 4. -2, 6. I'm going to make that connection here. And my last was going to be 5 and 1. All right, so that's how we're going to make our mapping diagram, all right? Based on our mapping diagram, right, is this thing a function? Hopefully you answered it is not a function, right? Because I have multiple outputs coming from one single input, right? This -2 goes out to the 3, and it goes out to the 6. as well as this 5 going out to the 1 and the 4, right? So 2, definitely not a function on this one here. All right, so little summary here, little recap. How do we tell if a relation is a function looking from a graph, right? If we're looking at a graph, right, we're going to perform that vertical line test. Right, sometimes you'll see me, so you see us write it as the VLT. All right, so that's how we're going to tell from a graph. And if we're looking at a table, at mapping a chart or ordered pairs, right, we're looking for repeating x values. Right? Are there any repeating x values or inputs or domains? Right? And if so, not a function. All right, so we're going to move on here. We're going to actually use our space down here below to write a couple more notes about discrete and continuous functions. All right, so we're talking about discrete functions. All right, we're talking about functions or graphs that are just made up of dots or points, right? Kind of like that above example. So on our discrete functions or discrete graphs here, right? Or let's talk about our domain and our range. All right, when we talk about our domain of a discrete function, right, we're just simply going to list out all the different x values, right? And we're going to put those in those curly little brackets. And when I talk about my range, I'm going to talk about just my y values. And again, I'm going to put those in those curly brackets. However, for both of these, right, there are a couple extra rules I need to know and need to remember for my discrete function when listing out my domain and range, right? And here are those two rules, all right? For both of these, right, we're going to put these in order, right, from least to greatest. All right, so that's kind of the first rule what I got to do with my discrete function. And the second rule is, so first, right, we're going to put them in order from least to greatest. We also do not want to repeat values, all right? Do not repeat values. All right, so that's like what we did on number 4 here above, right? We didn't repeat our values in our domain, right? And we did not repeat values in our range for our map and diagram. All right, and we put them in order from least to greatest. All right, so that hopefully helps with this discrete function. All right, and then the other type of function we're going to be dealing with, right, is our continuous function. All right, so for our continuous function, right, remember these are the connected ones, our connected graphs, right? We can connect all the points there with a single stroke of our pen here. All right, so for our continuous function, right, our domain, right, this is going to be how far left and right does the graph go? And how far left, and then how far right does it go? And for my range of a continuous function, right, that's going to be how far down and up does it go? All right, how low does it go? How high does it go? And for both of these, right, when we list out our domain and my range for my continuous function, right, we're going to use that interval notation. Right, that's going to be the brackets and parentheses with our infinity symbols. Right, we're going to use interval notation when we're writing out our continuous function with our domain and range, right? So our continuous function is going to look like these types of graphs here, right, that are all connected. All right, now let's take a look at one more example here, right? We're going to jump to page 114 here. We're going to look at this first example here. Now we're going to state the domain of this relation, right? And this is a bunch of ordered pairs. So this is definitely discrete, which means I'm going to just list out those x values for my domain and then list out those y values for my range without repeating. All right, so for my domain, again, I'm going to use those squiggly little brackets here. All right, doesn't have to be perfect. You can look at mine, right? So now we're just going to look at those x values here. All right, 4, -6, 2, -6, 0, and 3. So again, list these in order from least to greatest and no repeats, right? So I got -6. It looks like my next one is going to be 0. And then I'm going to go to 2. And then I'm going to go to 3. And then I'm going to go to 4 here. Now I'm going to list out my range here. And again, if you notice on my domain there, right, I had 2 -6s, but I did not write both of them down, right? We're just going to list out, we're not going to repeat any values here. All right, so now for my range, again, we're going to list them in order from least to greatest and no repeats, right? And we're doing it this way because this is a discrete function. All right, so it looks like my lowest value is -3. Put these all in our blue here, right? And then we go to 0, is my next one. And I have 1. I have 5. And I have 2 7s, but again, we're only going to list one of them, right? We're not going to repeat values within our range. We're not going to repeat values within our domain. All right, and now we're ready to go ahead and make a table, and then we're in the graph after that. So again, when I'm making my table, right, it's just listing out those same exact ordered pairs, right? You will repeat here, right? If there are repeats, you're going to repeat them, right? We're just going to rewrite those ordered pairs. So we have 4, 5. We have -6, 7. We have 2, 0. We have -6, -3. We have 0, 1, and we have 3, 7. And lastly here, we're going to go ahead and plot these points on our tables. All right, I'm just going to zoom in a little bit so that I can get these a little more accurate here. All right, so our first point here is 4, 5, right? So again, this is going to be my x-axis. This is my y-axis. This is my y-axis up here. All right, so 4, 5. I'm going to go 4 on my x. 1, 2, 3, 4, and 5 up. 1, 2, 3, 4, 5. That's going to be my first point there. -6, 7, right? -6 on my x is going to be to the left. 1, 2, 3, 4, 5, 6. And then 7 up. 1, 2, 3, 4, 5, 6, 7 up. There's -6, 7. Then we have 2, 0, right? 2 on my x, 0 up on my y will be right there. -6, -3 to be -6 to the left on my x-axis. So -1, 2, 3, 4, 5, 6. And I'm going to go 3 down. So -6, -3 will be right there. Then we have 0, 1. So that means 0 on my x, and then 1 up. And lastly, we got 3, 7. So we're going to go 3 to the right. 1, 2, 3. I'm going to go 7 up again. 1, 2, 3, 4, 5, 6, 7. All right, and actually for our last example here, we're actually going to have you complete number 2 here. All right, I want you looking at number 2 here. We're given a mapping diagram, and I want you to be able to determine your domain and range. Again, this is a mapping diagram, so this is discrete. So we're just going to list out the elements from the domain. We're going to list out the elements for the range there. And when we're looking at this mapping diagram, each one of these arrows, right, is going to be your ordered pair, right? So for example, we're going to have -3, 6. We're going to have -2, 1. We're going to have 0, -3. We're going to have 2, 1. And we're going to also have 3, comma 6, right? All those arrows show the connections for your ordered pairs. All right, so go ahead and use that information to determine the domain and range. I want you to create a table as well as to graph that relation. All right, and when you're done with that, go ahead and scan in both of these pages of notes. Right, we're going to scan in page 112 as well as scanning in page 114. That'll be kind of our lesson today, and that'll be kind of like your classwork. So just be sure to get this done before 10 p.m. today. All right, and then we'll be back in the classroom tomorrow.